Hello, this is Albert van Dijk, and this video introduces the first lab tutorial. And that first lab tutorial in the remote sensing component of this course is about how to use Matlab and some basic image processing. So let's have a look at that. So the goals of the lab tutorial are to familiarize yourself with Matlab, to open imagery, and to process imagery. So you could ask, why are we using Matlab in the tutorial when we had ArcGIS in the previous semester? Why don't we just continue with ArcGIS? You could also ask why Matlab and why not other possible software tools that you might have seen or heard of, such as Python or R or NVIDL. These are all fair questions. So the reason we're not using ArcGIS is because we're basically going to provide a set of commands that will automatically analyze raster data. And while that is technically possible in ArcGIS, that's not so straightforward. So last year you would have done a lot of things manually. You would have clicked a lot in ArcGIS. Once you start getting away from clicking to things that you can automatically repeat, then you need some sort of programming environment. And so that's what we're going to do. We're going to do a little bit of programming here. And the reason we chose Matlab and not, for instance, Python is that we wanted to use an environment that is readily available, that won't fall over, that won't have any version or other compatibility issues, and that does have a fairly extensive help function. So we're going to look at how you can invoke help in Matlab, but it's one of the more the better features of this programming language. Having said that, Matlab has got downsides as well. For starters, if you're not in university, you're going to have to pay for a license, and that's why I'm certainly not saying that you should always do these things with Matlab. In fact, Python is rapidly becoming a more common and more appreciated and free tool to do these sorts of analyses, but it's not quite as polished as Matlab, and that's why we use Matlab. All right, so Matlab stands for Matrix Laboratory, but essentially it's designed to work with matrices. And as we'll see, an image raster data is a form of a matrix, and that's why Matlab is quite useful to work with those data. When you're going to open Matlab, you'll see something like this. You'll see some sort of big empty white window, which is probably the command window. It will say here at the top as well what it is, of course. You'll see the workspace, which basically shows you what variables are in memory that you can call, that you can ask for if you like, and you'll see the command history. That's just a list of all the things you've typed so far in the command window. And you can see the current folder, which gives you all the files available in the folder, much like Windows Explorer would. And of course, there's a toolbar with tabs that you can switch between. All right, so that's what Matlab looks like when you open it. So where do you start with Matlab? If you've never done programming before, this is going to be maybe a little bit scary, but don't worry, it's actually not nearly as scary as it seems. Basically, you can start typing away. So you can ask Matlab a question, for instance. So you could say, you could type in the command window 3 plus 3, and you can press enter, and then Matlab should be telling you the answer to that is 6. So that's how Matlab works. You ask it to calculate something, essentially. Now, so that you can keep track of what you've asked it, you can look at the command history, but you can also start writing a script. And a script is basically a recipe, if you like, of the different commands that you've given in Matlab. And then you keep a record of that in one file. It's called an M file because the extension is M. And you basically keep track of everything you tell or ask Matlab. Now that gives you an ability to repeat the whole process very quickly again later on. So that's why these M files, these scripts, are useful. So a few things to know about talking to Matlab, if you like, is first of all that like most programming languages, Matlab is extremely sensitive. You have got to ask things the right way. If you make a spelling mistake, it won't understand you. It's also case sensitive, so if you use a capital where you should be using a lowercase, it won't understand you. If you put a bracket wrong, you forget to add a bracket, it won't understand you, and it will say so. If it doesn't understand you, it will tell you, I don't know what it will give you an error essentially. A few other basics. Matlab works with variables. So what you could say, for instance, you could create a variable x, and you could say that equals 5. And if you do that and you press enter, then you'll see it appears in the workspace window, and it will have a value of 5. So that's how Matlab describes variables, much like you would in mathematics, of course. So x is 5 here, it creates a variable with a value of 5. I can also create a matrix, so a two-dimensional array of columns and rows with numbers in them. In this case, 5 columns and 5 rows. Or I can create a single array, in this case, 1 row with 12 columns, or 1 column with 12 rows. So there's these concepts called matrices and arrays. Now, if you've done mathematics, this won't be a surprise to you. So the questions may be, then how can I start getting data out of that matrix? Well, that's how you do that with identifiers or coordinates, or whatever you want to call them. So basically, you say, okay, so I've got this matrix, it's 5 by 5, but I want the value here, for instance. And then the way you say that in Matlab, and this is something that varies rather a lot between different programming languages, you said I want the third column in the first row. In other words, the first row it means 1, and the third column is 3, and so I'll ask for the number that is in matrix on this location, row 1 and column 3. Now in other languages you might actually start counting at 0, or you might put the columns before the rows. So that's where you got to be careful when you use another language to do these exercises or analysis. I can also just ask for the first element. If I ask for matrix 1, that just gives me the first number. That can be quite confusing though, because if you want to use it that way, you'd have to know that Matlab counts like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you've got to be careful using coordinates like that. And here's an example. If I want to have the first column in the third row, then ask for matrix, bracket open, 3, 1, bracket close. And it should give you 3 if you're using this metric. All right. So why is that useful? Well, because basically imagery is made up of matrices. So even if you look at the picture like this, picture of peppers here, it's got 3 bands. You never see that because you look at the images it displays on your screen. But if you were to go look into what it constitutes, how this data is made up, you'll see it's got 3 different bands, 3 different matrices, each of which code for red, green, or blue. And when you combine those 3 colors, you see what you see here on the screen. And this is sort of shown here. So I've got one matrix with all these numbers here, one matrix with all these green intensities, if you like, and one with the blue ones. In this case, they're probably between 0 and 1. In other words, 1 means you get full saturation in red, and 0 means no red. And you can do that for the 3 colors, and then it combines into different pictures. And so you see white here will have 1 in red, green, and blue. That's why it's saturated, and black will have 0, 0, 0 in all the 3 bands. So in red, pure red without any other sort of hues to it, if you like, will be 0 in blue, 0 in green, and 1 in red, and so forth. So that's how color coding works in red, green, blue imagery. And we're going to open one of these in this course. In gray imagery, you only have 1 matrix, and that codes for, as you can imagine, the intensity of white. So again, black will have a value of 0, and white will have a value of 1. All right. So we're going to do that. We're going to open this image, which is of controlled burning on Black Mountain, and we're going to use these commands. So Matlab has got a number of commands, quite a large number of commands, in fact, where you basically tell it to do something, given certain inputs that come after the command, and it will understand what you're trying to do, and it will do that for you. If you want to know how to use this command, you can use the help or the doc function. So here's an example of where we did exactly that. You'd say help, imread, and this is what we get. You can also use doc. In that case, you get a window separately from your command window, where it gives you all that information a bit nicely formatted, and that has the benefit that it's not clogging up your command window. so you can use either. Alright, so one thing we can do, and we're going to do in this lab tutorial, is to change the red, green and blue values and see what that does. We're going to we're going to really amp up the blue, and then we're going to see that. We're also going to look at some hyperspectral imagery of ANU campus in much more detail, which gives you much more spatial detail. There's the hyperspectral imagery has got, of course, many more bands, but we're only going to use 4. And here's an example of NDVI image that we've derived from the hyperspectral imagery in a pop-up figure window within Matlab, and you should be seeing something like this as part of the tutorial. Okay, well that was a brief introduction to this first tutorial, and I suppose don't forget to enjoy the exercise because you're learning some important skills. Don't be worried that it's don't be daunted by programming, because programming is just another word for writing down in a structured way what you want the computer to do for you, and you'll start to appreciate the great benefit it has over manual clicking, in that you're going to have less sore hands and wrists, and you'll be able to repeat exactly what you did before with one click of a button. So I think just enjoy it, and good luck with the exercise.